In this video, we are going to go over what a system of linear equations is, as well as figuring out how to determine if a couple of numbers makes up a solution to a system of equations. Let's dive right into it first by discussing what a system of linear equations is. A system of linear equations is two or more linear equations. That's it. So I've actually given for you right here a system of linear equations. You have y equals 2x plus 5 and something not quite written in slope-intercept form, x plus y equals -1. Both of which are linear equations, so we have a system, more than one, linear equations. Now, what is the solution to a system of linear equations? Well, a solution to a system of linear equations is a set of variable values, so set of values, in this case there'd just be two of them, x and y, that when we input them into each equation, those equations are both true. So in other words, we're looking for a solution to both equations, that same solution. So we're asked, is -2, 1 a solution to the system of equations? If it is a solution to it, then the x value, -2, and the y value, 1, should make both equations true. If one equation is true and the other one is not when we plug it in, it's not a solution to the system. If they're both not true when we plug it in, then it's not a solution. Let's check it out. So very simply, we're just going to input these values into their corresponding places. So we take -2, 1, plug it in, y is 1, x is -2. So I multiply x by 2 times -2 plus 5. And if we check this out, we'll just go over a little bit further here, little arrow. We see that 1 is equal to 2 times -2 is -4 plus 5. Well, that's going to be 1 is equal to 1, right? Because what we're doing here is -4 plus 5. So that means that the point -2, 1 is on this line, or in other words, it is a solution to that first equation. Is it a solution to this? Let's see. We'll plug in -2 for x, and we'll add to it the y value, which is 1. And now we need to evaluate whether or not that is true. Well, -2 plus 1 is -1, I believe, right? Because we'd get -1 on the left side here is equal to -1. Since the point -2, 1 made both of these equations true, we know that it is indeed a solution to the system of equations. Now, another powerful way of understanding this is seeing why the solution to a system of equations can occur when two lines cross each other. So in other words, another way of looking at this is -2, 1 is the location on the graph or on the coordinate plane where this line will cross that line. I'm going to go over that now so that you see this as both a numerical understanding as well as a graphical. So let's graph out y equals 2x plus 5. We'll start out with the y-intercept, which is 5. So we'll go up 1, 2, 3, 4, 5, and then use our slope, which is 2. So that means rise 2 and run 1, right? You can look at it as 2 over 1. So I will rise 2, 1, 2, and run 1. Rise 2 and run 1. And then I'm actually going to go in the other direction just to extend the line as much as I can in both directions. So we'll go down 2 and left 1. Down 2 and left 1. My tip for you here is draw a whole bunch of points when you're trying to show graphically where solutions are. Now, how do we graph x plus y equals -1? Well, in future math classes, or maybe you've already learned this, you could graph this using what's called standard form. I'm not going to show it that way. I'm going to do this with slope-intercept form. So I want this to be in the form of y equals mx plus b. To get there, I'm simply going to subtract x. That will get me in the form that I want. So if I subtract x from both sides, like so, I get y alone, and I get y equal to -x minus 1. Now let's graph that out. The slope on here is -1, so you could look at that and think, okay, my slope is -1 over 1, and my y-intercept is -1. So I'll start at -1 down here. Boop. And now I'm going to have a slope of down 1, right 1. So I go down 1, right 1. Down 1, right 1. And I'm going to go in the opposite direction as well. So up 1, left 1. So that'd be up 1, left 1. Oh, look where it's heading towards. Up 1, left. Ah, the same exact location. So this line right here, if you were to draw out just a rough sketch of it, here, and this line right here, they cross at what point? Negative 2, 1. So it's the whole idea that if this solution worked in the original line equations, in the original linear equations, then we know that that point would be on both graphs. And if we have a point on both graphs of those lines, then the lines are going to share that space at negative 2, positive 1. Or in other words, they will intersect there. So yet another way of understanding a solution of a system of linear equations is, where do those lines cross? And here they cross at negative 2, 1. So this has been an introduction to what a solution of a system of linear equations looks like, as well as giving you a little tip of how to solve a system of linear equations by graphing. In later videos, I'm going to just start out by saying solve by graphing. I'm hoping you watch those. It's going to be a great connection with what we just did here.